This is test 65, section 4, question 1. When a forest is subject to acid rain, the calcium level in the soil declines. Okay, if you say so. That's a conditional statement. Whenever a forest is subject to acid rain, then I know for sure that the calcium level in that soil has to decline. I don't know how much. I don't know what the starting level of calcium is. You know, I don't know what the end result is. I just know that it has to be something less than it was before. Spruce, fir, and sugar maple trees all need calcium to survive. If you say so, you know, you connect those two ideas together and you get an inkling that acid rain might be particularly bad for spruce, fir, and sugar maple trees, at least to the extent that they need calcium, and acid rain tends to decrease soil calcium. But be careful. It's not, you know, you don't get to just leap to some conclusion that therefore anytime there's acid rain, spruce, fir, and sugar maples do terribly, because if they're in soil that had a huge amount of calcium to begin with, maybe they're fine. Or maybe they don't need very much calcium, so the calcium level can decline and these trees could still do fine as far as we know. However, sugar maples in forests that receive significant acid rain are much more likely to show signs of decline consistent with calcium deficiency than are spruces or firs in such forests, and that sets up a bit of a mystery for us. I am expecting this to be a paradox question, because we have a puzzling set of circumstances. Spruce, fir, and sugar maple trees all need calcium to survive. Acid rain tends to deplete the amount of calcium in soil, but sugar maples do worse on the calcium deficiency than do spruces or firs in the same forest. What's up? Well, maybe sugar maple trees need more calcium than spruces and firs. Like, they all need it, but maybe sugar maple trees have a real high amount that they normally need. Or, you know, it could even be something bizarre. Like, what if acid rain had other characteristics that was actually good for spruces or firs? Like, yes, acid rain decreases the amount of calcium in the soil, but acid rain adds to the amount of phosphorus in the soil, which helps spruces and firs process calcium more efficiently. Something like that would be a great explanation. I could go on all day with 100 different explanations, but I'm not going to. The important bit here is that I know what paradox I'm trying to explain, which is, hey, why are the sugar maples doing worse on the calcium deficiency than the spruces and firs? And I've come up with a couple of possible explanations. The correct answer doesn't have to match exactly my prediction, but it's going to be that same type of thing where it's going to basically scratch the itch. The itch is, hey, why are sugar maples doing worse? The correct answer is going to satisfy that. It's going to say, oh, well, here's a good explanation for why the sugar maples are doing worse than the spruces and the firs. A says, soil in which... Oh, by the way, I didn't read the question, did I? I predicted the question. Which one of the following, if true, most helps to explain the greater decline among sugar maples? Explain. Really important word there. This is a paradox question. We have to know what the mystery is, and we have to explain that mystery. A, soil in which calcium levels are significantly diminished by acid rain is also likely to be damaged in other ways by acid rain. You know, if that's the case, maybe they should, all the different species of trees should be doing terribly. I don't see how A, in the slightest, explains why sugar maples specifically are doing worse than the spruces and the firs. That is not a satisfying explanation to the mystery that we were asked to explain. B, sugar maples that do not receive enough calcium deteriorate less rapidly than spruces or firs that do not receive enough calcium. That actually makes the paradox worse. I mean, they said sugar maples in forests that receive significant acid rain are much more likely to show signs of decline consistent with calcium deficiency. B says sugar maples should actually do better in conditions of calcium deficiency. So that's surely not an explanation. C. Spruces and firs, unlike sugar maples, can extract calcium from a mineral compound that is common in soil and is not affected by acid rain. This is a perfect answer for this paradox question. It's a difference between sugar maples and the other two species of trees, and it's a difference that helps explain why the spruces and firs might not be doing so poorly in acid rain conditions. They have another way, basically, to get to the calcium. The sugar maples don't have that way of getting to this alternate route to getting the calcium. That's why sugar maples are observed to do worse in forests that are subject to acid rain. It's a perfect answer because it's a satisfying explanation to the paradox. D says sugar maples require more calcium in the spring and summer than they do in the fall and winter. What's that have to do with acid rain? What's that have to do with why they're doing worse? I'm glad that it looks like none of you in the class were interested in that answer at all. E says, unlike spruces or firs, most sugar maples are native to areas that receive a lot of acid rain. Well, if they were native to an area that receives a lot of acid rain, wouldn't they have evolved like a coping mechanism for acid rain? To me, E doesn't explain anything. Why would they do worse if they're native to areas that get acid rain? It's not an explanation. It actually makes the paradox worse. So I think both B and E make the paradox worse. D and A just aren't helpful. They just don't scratch the itch. The answer here is C because it's the only one that gives a satisfying explanation for the paradox, which was, why are sugar maples doing worse?